Okay, I think it's about time we can get started here. I'm Alan Wirfs-Brock, and I was the project editor, which I'll explain what that means a bit more, of the ECMAScript 2015 standard. And what I want to do today is kind of let you peek inside what is the process of creating a JavaScript standard and such. I'm sure here over the course of this conference and the classes you've heard a lot about ES6 or ECMAScript 2015, and you'll have to pardon the slides here don't quite fit on the projection here and stuff. But yeah, so ECMAScript 2015 is also known as ES6, is the new JavaScript standard. Just if you wonder where any of these naming comes from, whoops, sorry, here, back, is ECMAScript 2015 comes from the year of its publication, and ES6 comes from that it's the 6th edition of the standard. And for years, this was sort of the working name for it, and about the time we published it, we decided we were going to switch to a year-based name, but it's all the same thing. Whether you hear ES6 or 2015, it's the new standard for JavaScript. So I've seen over the years lots of confusion about what ECMAScript means and what's the relationship between ECMAScript and JavaScript, and I just sort of want to make sure to explain it. ECMAScript is nothing more or less than the standard that defines what JavaScript is. So ECMAScript and JavaScript are the same thing. Sometimes I run into people who think, well, there's actually kind of two different languages. There's ECMAScript, and then there's JavaScript, which is a dialect of ECMAScript, and you can have a version of ECMAScript that isn't JavaScript, and none of that is true. It's basically, they're the same thing. And in your everyday life, talk about JavaScript. That's really what matters. You're using JavaScript, you're programming in JavaScript, and hopefully you expect the platforms you use JavaScript on, whether it's browsers or Node or anything else, to be as current as they possibly can with the current standard for JavaScript. That's ECMAScript. Similarly, you probably shouldn't worry a whole lot about whether you're dealing with the 2015 or the 2016 or 2017 version of ECMAScript. You should be using the current version of JavaScript, and you probably won't have a lot of choice about that. So it's just JavaScript is what we're talking about here. So you can think of here sorry, I got to get used to the buttons here on this. So you can think of the standard up here, which is the specification of what you have to, how a JavaScript implementation is supposed to work, what it's supposed to do, and that's the specification that everybody who implements a JavaScript engine then follows that and writes tests to make sure they conform to it and stuff. So just to really get nerdy, standards nerdy about this, so the ECMAScript standard is developed by a group called Technical Committee 39, or TC39. It's a technical committee of ECMA International. ECMA International is an organization based in Switzerland that hosts the development of standards. And there's all sorts of legal mechanisms and stuff around what it means to develop a standard. And ECMA provides that infrastructure. TC39 is the group of technical experts who actually sit down and write the standard. ECMA 262 is a term you might hear sometimes. Standards organizations like ECMA love to assign numbers to things and stuff. And so ECMA 262 is simply the document number of the ECMAScript standard. And it goes through various editions as it evolves. And finally, something, none of this process of standardizing ECMAScript involves W3C. Now, which is, a lot of people find surprising. I mean, clearly JavaScript is a major component of the web platform, but it's not a standard developed by W3C. It's developed by ECMA, and there is really no formal cross-fertilization between those organizations. Now, in fact, the same companies are involved as members in both organizations, and sometimes even the same people are involved in TC39 as are involved in the development of various W3C specifications. So there's lots of cross-fertilization in that sense, but in terms of formal organizational coupling, there really isn't any. Okay, so kind of the backstory here. Probably most of you have heard the JavaScript origin myth that Brendan Eich at Netscape in 10 days of May of 2095 sat down and implemented JavaScript. Now, I think the reality is there's quite a bit of thought went into what was going to happen before those 10 days, and after the 10 days, there was, kind of a standard development process of evolving before it finally shipped. But the core of the design of JavaScript is what happened in those first 10 days. Within a year after that, JavaScript had been cloned into Internet Explorer by Microsoft, and they called it JScript. And so suddenly the web had two implementations of this language that for web pages to work, they needed to interoperate or work the same. And so there was a need of a standard. And the interested parties, including people from Netscape and Microsoft and some web developers, got together, worked with ECMA to go start the process of defining a standard, and that created ECMAScript 1, if you will, the first edition of the ECMAScript standard. And then over the next couple years, two more editions were worked on until at December 1999, the ECMAScript 3 specification was published. And ECMAScript 3 essentially defined the baseline of what everybody knows of today as modern JavaScript. Before ECMAScript 3, there was things like exception handling and regular expressions, and a number of important features weren't present in JavaScript, but kind of all the sort of normal core JavaScript that you expect to use every day was kind of defined there in 1999. So then after that, I call it ECMAScript's troubled adolescence. There's basically, right away, right after ES3 was done, there was an attempt to do it right. I think of this as the ECMAScript second system syndrome point. The very same people who worked on ES3 sat down and created a much more ambitious specification that had many, many more features, and then nobody implemented it for various reasons. And sort of the whole activity to define a new version of ECMAScript ended, and some work happened. Sort of the XML people came in at the time, so this was a time when XML on the web was kind of gaining interest, and so there was a lot of work that went into trying to say, how does XML fit into ECMAScript? That sort of was finished and petered out. There was another attempt to do an ES4. It went on for about 3 years before that work was abandoned. In parallel with it, kind of a much smaller effort that was called ES 3.1 started as sort of a TC39 side project to clean up some things from ES3 and kind of as a backup in case ES4 didn't work out. It didn't work out, and so in 2009, ECMAScript 5, the work that was ES 3.1 ended up being published, and it was rebranded as ES 5. And it introduced things like strict mode, JSON, object create, a relatively small number of features. But really didn't, it was very limited set of extensions. So if you look at it on a timeline, And unfortunately, the scale here doesn't work all that well. But it's kind of like there was a nice period of rapid development of standards, and then everything went off here into this black hole of ES4s and E4X and what have you. Now, during that period, it was interesting because one of the reasons I think the original ES4 didn't get any traction was, well, people were just starting to use ES3. They really didn't know how JavaScript was going to be used at scale on the web. And during this period of distraction, well, Ajax, sort of the Web 2.0 view of the world emerged. And so by the time we got out here to where it was time to actually codify ES5, there was now a lot better understanding of what the web really needed in terms of extensions to JavaScript. And it also gave room here for the JavaScript performance evolution, where the performance of JavaScript engines increased by orders of magnitude. And again, that's one of these things. Would this have happened if there was a major new version of JavaScript to implement? Maybe not. So basically, once ES5 was done, then the serious effort got underway to really do a major new revision, and that ultimately became ES 2015 or ES6. And I'm not going to make any attempt here to try to go through all the details, features of what's in ES6. There's other talks here in classes that go into that. But I want to kind of give you a sense of the scale of scope here. Now, you can't really see down here at the bottom here in the black, but ES1 was a 110-page spec. Okay, so you can kind of see how the growth of the spec, 110 pages, 117 pages, 188 pages, 252 pages, and 566 pages. So I really have a good scale here that ES6, or ES 2015, is really a major, major, major revision and extension of the language. And it really is a culmination of kind of the 15 years of evolution of the language from where ES3 was in 1999 to what we have today. So, one of the things people wonder, well, how does TC39 work? What it's really like when TC39 gets together to meet, and what goes on there, and how do people interact? And I just give you kind of two things people imagine, which isn't it. I mean, it isn't a giant, formal, parliamentary style meeting with hundreds of people and very strict and formal processes and stuff. So that's not what it's like. It's also not a smoke-filled room where you can imagine here, I don't know, you can imagine, Google and Microsoft and Mozilla and Apple kind of getting here together with their chips and making deals about what's going to happen. It's really not like either of those scenarios. This is a picture of an actual TC39 meeting from last summer. It's a room full of people. The people there, formerly the members of TC39 are organizations, are companies. And, so people like Google and Microsoft and, Mozilla, but also companies that have an extensive investment in using JavaScript, which is almost everybody these days. But like, Twitter and PayPal and Salesforce, who recently joined, these are the formal members of TC39, and then they all appoint people to represent them at these meetings. And the people who are sent to these meetings, it's up to each company to decide who to send, but generally they're people who are language experts, either at language design or language implementation. They may also be people who are sort of expert users of the technologies, of application developers and stuff. But everybody gets together, and what really, this is essentially the JavaScript design team. Gets together and have technical discussions about how the language should evolve, when features are proposed. We talk about the features, why the feature would be useful, what use cases it supports, how it fits with other parts of the language. So it's getting a little large. It's grown over time, but it is a very, very technically focused group of people working on technical problems. So just a sense of it as we went into working on ECMAScript 6, these are the sorts of things we were looking at. You know, what was missing in JavaScript? What was holding it back? And so issues like modularity and better abstraction capabilities, how to make the language clearer, more expressive, less error-prone, and something we explicitly were thinking about, this was 6 or 7 years ago, was this idea of a better compilation target. We're anticipating more and more use of languages that compile the JavaScript, and so we wanted to make sure that the new version of ECMAScript we actually considered what transpilers or compilers of various sorts would need. And I guess an overriding thing in all this as we think about the language is, what are the things that can only be done by TC39, by the designers of the language? If things can be done in a library, essentially if you can write a polyfill for it, maybe it doesn't need to be in the standard, right? But if things that only the standards body can do is, you know, define new syntax for the language, change the semantics or add new deep semantics into the language. And so that's why you tend to see those are the sorts of things there's a lot of focus we have on. So as we sit here in TC39 and have these discussions, you know, it's just like any other discussion about JavaScript and the future of JavaScript you might imagine, right? We think about what kind of language is this? You know, is it functional? Is it object-oriented? If it is object-oriented, what style of object-oriented? Is it permissive? Is it secure? We continually talk and we continually fight about these things, but we kind of fight in a playful way, you know, like our dogs here and stuff, because we really are trying to find the medium of what JavaScript needs for all its users. JavaScript really is a multi-paradigm programming language. It really is all these things. And one of our challenges is figuring out how do we balance these. If we go too far one way towards functional or towards object-oriented, then it may disadvantage people who wanted to use the language in the other way. If we make it too secure, then the people who enjoy the permissiveness of JavaScript may not be served. So we have to find a balance between all those things. Another thing we have to do is JavaScript, going all the way back to those 10 days in May, has a whole lot of baggage built into the language. And wouldn't it be nice if you could really clean up some of that baggage and get rid of some of the error-prone features, for example? But really, our number one overriding principle is don't break the web, right? So there's lots of things we'd like to do. Well, no doubt we would argue about exactly what those things are, but we would find some agreement. There's lots of things you would like to do to improve the legacy baggage that comes along with JavaScript. And in many cases, we simply just can't do it because it would break code that exists on the web. And we don't want to break anybody's code, right? So another thing we want to look at is, as we add new features and stuff, we really have to think carefully about how new features fit into the language as it exists. Or say here, we don't want to create a Franken language. We don't want to put the snazziest new functional feature on the language if it's not going to fit in well with what's already there. We have to find a way to balance all the new features and try to create a coherent whole out of it so that in the long run, when somebody comes back 3 or 4 or 5 or 10 years from now, they don't see the language as a set of kind of stratas that have fossilized over time, but they still see the language as a coherent whole. So one of the things, really common, I call this a meta tweet. I see tweets like this all the time. Somebody says, ES6, pick some feature, classes in ES6 is based on, insert your favorite language here. And there's a lot of, I would say, misperception that what a language design team, what a standards team like us are doing is we're simply harvesting features from other languages and we're shoving them into ECMAScript and we're taking them as we found them. And we almost never do that. As a group, we have broad experience with many languages and many styles of programming, and we understand many features in many different programming languages, and we try to evaluate them in depth of what really the core of these features are, what they provide to the programmer, and how we might integrate that. If that's a valuable feature, how it might be integrated in a coherent manner into JavaScript. So for example, here's a survey question here, is what language had the most influence on the design of ECMAScript classes? How many would say Java? Yeah, a fair number. That's just something that surprised me, is that so many people, just when they saw a class keyword, immediately assumed that ECMAScript 6 classes were based on Java classes somehow or another, or inspired from them. The answer for this is actually JavaScript was the language that had the most influence on ECMAScript class definitions. In fact, if you look at JavaScript has always had a latent class model. It's been there since ECMAScript 1. It manifests itself in how constructor functions work. It manifests itself in terms of how the built-in constructors in the standard library, how they work, and they all follow the same basic model of constructors with a prototype holding on the methods, which instances reference the prototype for inheritance, and you can inherit up the prototype chain. That is the latent built-in class model of JavaScript that Brendan and I coded up in May of 1995, right? And that is exactly what is implemented in ECMAScript 2015. On the left here, you have the code, the manual wiring code that you had to do at ES5 or ES3 to build that structure. What the class model in ECMAScript 2015 does is provide a syntactic convenience to say, I can create a single syntactic unit to say, I'm defining something that follows the standard ECMAScript class model. And so that's what ECMAScript 2015 classes do. It simply implements the model that's always been there. So that's why I say JavaScript is the language that most had the largest influence on ES6 classes. So basically, one of the things we're seeing here as we talk about all these features, as you're designing a language like this, you can't just take one feature and add it to the language and say, this is cool, this is how it works. You have to figure out how everything integrates together. Every feature interacts with every other feature, and you have to understand those interconnections and stuff. And so what I'm going to do here is I'm going to walk through kind of a set of steps here that show just kind of the reasoning and logic that led to one particular set of features in ECMAScript 2016. And so we're going to start here with the closure and loop problem that you might see in ES3 level JavaScript. And basically what we have here is we have a for in loop, and in this loop, a callback is being associated with some object, and that callback is passed as a function object, a closure, and that closure references two variables here, v and p, that are defined by the loop. And down here at the bottom, where you can't see very well, it's basically all those callbacks are being called. And those of you who are experienced JavaScript programmers probably see a bug here. A bug you probably encountered. The bug is that each of these callbacks that are installed in this loop all end up using the same value for v and p down here when the callbacks are activated. In fact, the values they use for p and v are the last values from the last time through the loop, where it's pretty clearly the intent of somebody who programmed this was thinking for each of these callbacks was probably capturing the value of p and v for the particular iteration of the loop where they created the callback. So millions of bugs in JavaScript programs are created because of this problem. It's just really too easy to do. So one of the things we wanted to fix for ECMAScript 2015 was to make it, to not have this hazard, right? To make it so people didn't use this pattern that would cause this sort of bug to occur. So how do you fix it? If you're at a language design level, how can you fix it? And what is the source of the problem? The source of the problem is that even though here in the for loop and inside the body of the for statement, there are these var declarations, what the semantics of var is really the same as if the vars were up here at the top of the function. These vars are hoisted to the top, right? So each time when you create this closure, what's being captured here by the closure, a reference to these function level variables, and when the function is evaluated, it's just getting whatever their current values were, which was what they had at the end of the loop, right? So hoisting is what caused the problem. And so you might say, well, an easy fix of this would be, let's redefine var so it doesn't hoist. And then if each iteration through the loop has its own var, then we don't have that capture problem. But unfortunately, people write code that depend upon var being hoisted, even being hoisted outside of a loop. They write code patterns like this. And so if we change that in the language, we would break those programs, we would break the web. Can't do that. That's against our rules, okay? So we can't fix the problem that way. What we can do, while we couldn't change the meaning of var, we could add a new type of declaration that added a variable that had different sort of scoping. And so we added let, and specifically we added let as a type of declaration that doesn't get hoisted to the top of the function, but has each block that contains a let declaration, or in this case, the loop itself acts as a block, has its own distinct variable that shares the name v, but they're different variables. And when you do that, then each time you capture the closure, you're capturing a reference to the variable in that block, not the global one. And then you're and that way it works. Okay, so essentially every callback here gets a distinct binding for v and p. So that fixes the problem. But okay, so now that we've added this new thing, let, and we've said it's going to have this block level semantics, but what else? What are the other characteristics of let we have to worry about? Well, let's see here. So it turns out that JavaScript had a lot of legacy peculiarities with declarations. So we're talking here about declaring a variable. Well, here's a little function. Look at each of these red X's is in essence a different declaration of the same variable of X, right? X is the name of two different parameters. It's declared as a var. It's used as a for loop index. It's declared within the block of a loop. There's a function down here. There's a function declaration named X. And at the very end, somebody calls X. What's the value of X at this point in the program? Okay. It's well defined by JavaScript, but it is very... Basically, this is crap, is what it comes down to. Right? But it's crap we have to live with. But now we're adding this new thing, let. So what do we do with let? Do we give let the same WTFs that var had, or can we fix them somehow, right? So we got to ask ourselves a lot of this in the process. So you can think of situations how let might be misused. For example, what happens if you have two lets in the same scope with the same variable name? What happens if you have both a let and a var for the same name? Right. So remember, these are all new things. These are things that couldn't have occurred in earlier versions of the language because let didn't exist. What happens if you have a let X, but there's also a parameter named X? What happens if you have a let and a function? So yeah. But basically, there's all these different issues that come up. So the resolution we came to was, okay, these are new things. We don't want to duplicate these errors. We made them these static errors. So static error is an error that occurs at parse time. It's essentially the equivalent of what happens when you have a syntax error. So as we introduce all these new declarations, we had to define rules for what the error cases were, and as a way to eliminate all these issues. So ES6 basically has a set of rules, a set of really principles for declarations we ended up having to articulate to explain how declarations work in the language. So it's like, in any scope, every name has a unique binding. Basically, var and let declarations at the top level, you can have both a var and a function declaration, and they define the same variable, and you have to do that because that's how ES 1 through 5 worked. And kind of go down the list here of these. It's hard to read here because of the clipping and stuff, but it's essentially all the new declarations forms are much more restrictive about duplicate declarations, or different types of entities being declared with the same names, and it's only in places where we have to deal with the existing legacy code that we fall back to the rules that we had before that. So I just want to give you a flavor here of sort of the sorts of things we have to think about as we add these new features. We really have to think about the impact of the feature across the whole language. So what's next, basically? What's the next step in ECMAScript evolution? If you kind of followed history, you might say, well, 15 years from now, maybe we'll have would have the 7th edition, ECMAScript 2030, and it would probably be about 1,100 or 1,200 pages, and between now and then, it's hard to say what would happen, but it would probably be kind of ugly. So as we were developing ECMAScript 2015, it was clear that we needed to change how ECMAScript was developed. And well before we released ECMAScript 2015, we decided in TC39 that we would do incremental annual updates. So going forward, at least for the next few years, the idea is there will be a new ECMAScript spec revision every year. These revisions, for the most part, are probably going to be fairly small. But the idea is to keep a continuing stream of improvements to the JavaScript language, not bundle them all up for very long periods of time. So, And we also developed a sort of a process to understand sort of how features go, new feature proposals will go through TC39 and how they mature to the point where they're going to be ready to go into the specification. So, so features start here at what we call a straw man stage, which is basically, here's an interesting idea, or here's something somebody thinks would be good to add to the language. They go through a process of TC39, evaluating it, deciding that, in fact, yes, maybe there's a use case here that we need to support, refining, coming up with actually a proposed spec of how to approach the problem, refining that, and then eventually getting it to the point where there is a complete specification and that there is an implementation experience, preferably in browsers, that people have actually tried to implement that. And only when we get to that stage are things going to go into the actual specification. So what's new in ECMAScript 2016? Well, basically there's only two new features. There's a new array function and there's an exponentiation operator. That's it. That's the only thing that's ready. That's the only thing that's met the criteria. But the train is leaving anyway. Now, what this doesn't mention up here is there are dozens, if not hundreds, of actually bug fixes to the spec that's also in the 2016 edition. And that's as important, I think, as these new features, is the fact that we're able to maintain and correct errors and stuff as we go forward. There are a number of things that people thought were going to be in ECMAScript 2016 that didn't make it. Async functions, SMD support, some new string functions. There's a number of things. Various people had guesses about what was going to be in ECMAScript 2016, and in some cases, the champions of those features even promised they'd be in 2015, but they aren't, primarily because they haven't had enough implementation experience yet. So probably showing up in 2017, but we'll have to see. You know, kind of no more promises about when something is going to be mature enough until it actually is. So kind of summing it up here is kind of that's how we made ES 2015, and that's how we're planning on making it forward. It's a huge change to the language. It respects the language that's gone as it was before and what actually exists out on the web. I like to say it has legs, which I kind of represent like this. We've taken the baggage and we put some legs on it and stuff, and hopefully we've made a much better language. So that's basically it. I got here maybe 2 minutes here if anyone has a quick question or anything, but yeah. So decorators have interesting use cases. Decorators are a complex a complex feature that has lots of interactions with other features of the language, and it's hard to get those right. I think we'll have to see how decorators evolve and how they'll proceed down the maturity chart. I think it's likely we'll end up with something like decorators, but I personally wouldn't want to predict exactly when and what all the details will be. Yeah, front here, middle, yeah. Yeah, you. You know, I don't think there's very many. No doubt there's some people disagree. If you really want a function scoped variable, I guess that's a reason to use var, but I'd look really closely at what your requirement is and say, why wouldn't I want the let rules in terms of worrying about duplicate definitions and stuff, so I'd recommend using let, and only if you run into some unusual situation where let isn't doing the job for you, then go to var. But okay, on the left in the back here. Oh, okay, a different question I thought you were asking. Oh, gee. So there's an active programming language community, particularly academic programming languages. So I try to keep up on all that stuff. You know, I guess if just in the broadest sense, you just have to be be a programming language geek and follow that stuff. New ideas take a fairly long time to kind of germinate and become practical to the level where they might go into JavaScript, but they eventually get there. Was one more up here, I think, yeah, are you on the right? Yeah, by the, yeah. Oh, when does it leave? So it actually takes about 3 months to go through the bureaucracy of making something a standard. So the idea that it's kind of anointed as a standard in June, which means that the actual document needs to be complete in March, and to be complete in March, sort of really all the final decisions have to be made in January. And in fact, in January, there was a TC39 meeting, and that's where, you know, that final culling of the list was done. It says, yeah, exponentiation is ready, yes, array includes is ready, no, all these other things are out. So yeah, sort of kind of in January of each year, you would expect determination of what's going to be in and what's going to be out, and the actual finished document would be out in June. Okay, we're really out of time here, but I think we're up against a break, so was there anything else, any others? Yeah, right here in the middle. Yeah. So it's actually allowed people to be exposed and use new features much faster. So that's really good, and it's actually provided a way, in some cases, to actually get feedback on those features. So that's really, really good. And the fact that people are using them, I think, are actually driving browsers to implement things faster than maybe they wouldn't have otherwise. The one downside of it is sometimes transpilers implement features kind of early in the cycle, and things change because, you know, when things are in these early stages of development, TC39 can't make any promises about not making changes, or even that a feature will ever ultimately make it to the end of the process. Okay? So I'll be around, happy to answer any questions or anything, or argue about stuff or what have you. So thanks for coming.